Hey guys, so today I want to look at this circuit, which is pretty involved. We have a lot of resistors in what we call series and parallel, and the main method for actually simplifying this circuit is to look at it from what I call the outside in, where the outside is going to be the furthest point from the power source, and the inside is really anything closest to it. So let's start from this right side. The main thing that we need to remember is that when you have resistors in series, they add. So say R1, R2 are equal to the R in a series. Now, say you had resistors in parallel. They have this really funky property. So 1 over R parallel will be equal to 1 over R1 plus 1 over R2. So knowing these two facts, we're going to take this entire circuit and try and boil it down to just a power source and a resistor. So the first thing we want to tackle are these two resistors right here. Since they are in series, we just add them, and we can actually get rid of the majority of this. So when you add them, you replace it with an equivalent resistor of 300 ohms. Next, we actually need to go through the process of this resistor now in parallel with this resistor. When you work out the algebra, which is essentially 1 over Rp is 1 over 300 ohms plus 1 over 50 kiloohms. Notice how this is in kiloohms and not normal ohms, where kilo is the prefix for 10 to the 3, meaning this term is going to be incredibly small. Going for the algebra, which you can punch into a calculator, for this specific one, you get 298.2 ohms. Notice how it's very close to this value, because this is a very small number. So, again, we replace those two resistors that were in parallel with this one. But we see yet again, we have resistors in parallel. So we must do the same process. 1 over Rp, I'll call this 2, because the second time we're doing parallel. 1 over 298.2 ohms plus 1 over 5 kiloohms. We've already seen before that when you have this big a deviation, this term tends to dominate. But if you go through and punch this into your calculator, you'll get 281.4 ohms. Again, pretty darn close to this resistance value. When you do such, let's move our ground over here. The new resistance value is going to be a nice 281.4 ohms. And we have nice resistors in series. So we can cancel this one, just add their respective values, and we will get the grand finale of 10,281.4 ohms. And this is your final resistance value.